Welcome to today's ArcGIS tutorial. I'm Abhradip Biswas here with you. Currently, I'm studying in Khulna University of Engineering and Technology. Today, we will learn about Project 4, that is Spatial Modeling of Minerals over Bangladesh. So first, we have this Excel data of manganese levels in different union parishes of Bangladesh. So our first task is to join this data in ArcMap software. In ArcMap, we have these three different layers. Among them, we need to join our data in the union layer. Before that, we need to add the Excel data here. For that, we'll go to add data, and this is our Excel file. We'll go inside of it and take database from it. Now, we need to join this Excel data with this layer. So we'll go to this layer and go to join, and in the field we will choose UP name, and we'll keep all the records, and then we'll click OK. Now you can see the manganese level data is joined with this layer. You can see there are a lot of null values because we don't have the data for all the union parishes. Rather, we have the data for limited union parishes, so we don't need the null values. To clear that, we'll go to selection, select the attributes, and in the field we will just choose, to clear it, manganese is not null, and then click OK. You can see there is some selection. Now if we open the attribute table, you can see that the areas that have attributes or minerals value are selected. Now we just need to export this data. We will go to data, export data, selected features, and we'll save it in to this outputs. Just select points and then save it, and we will add this as layer. Now we don't need this, we just need these parts. Now we will use interpolation techniques to determine the values in the whole Bangladesh. But we have a problem here. We don't know which interpolation technique is suitable for our study area. For this reason, we'll apply 4 different interpolation techniques and then use a RMSE calculation to determine the best technique. Before using any interpolation techniques, we need to divide our data into 2 parts. And for that, we'll use random sampling to execute random sampling. We have a tool. The tool is geostatistical analyst, that is it. I have already enabled it, so I'll just go here and I'll click subset features. In the input features, we'll select point manganese, and in the output training, we'll first name training, and in the second one we'll just give the name test. And for the size of training feature, we'll select 80, and the 20 will go to the test. We'll divide our data in 80-20 ratio. Then we'll just click OK, and you can see we have 2 points here. Now we will just change the symbol of it. The test will keep it red like this, make it 10, and for the training we'll use the green, symbolize, and uncheck the other layers. Now we are ready for our interpolation. We'll use this training layer of training points to interpolate our data. So first we'll apply the IDW interpolation. In the point feature will use training. In the G field will use manganese. We will choose 50 as cell size. The name would be IDW MN 50. And in the environment we have some changes. In the processing extent we'll choose same as their AI, and in the raster analysis we'll choose mask AI and then click OK. Now we're done. We have to just click OK to start the interpolation. Now it will take some time. I will just fast forward. You can see our IDW is completed. Now we will perform Kriging. So just go to Arc Toolbox, and the Krigings will use the same parameters. Output cell size will be 50, and in the name we'll write kg mn and 50, and in the environments we'll choose same similar things that we have chosen before, and then click OK. Then click OK again. Now I'll wait for the result. It will take some time. So our Kriging interpolation is completed. Finally, we have one interpolation technique left, that is Spline. We'll apply this. Go to Arc Toolbox, then go to 3D Analyst and Interpolation and Spline. In the input points, we'll choose training as before. The Z field will choose this, and we'll name it SL 52. Okay, we give it 50 with raster regulation, and the extent will choose AI, and in the analysis we'll choose AI as well, mask. Then we'll click OK and check the results. 4 out of 4 interpolation is completed. Now we'll analyze which one is better for our this particular data type. Now to analyze this data in Excel, we need to merge the raster values with our test dataset. For that we have a tool, that is extract multi values to points. Now in the input point features we'll choose test, and in the rasters we'll choose one by one. That means all 4 of our interpolations, and then we'll just click OK, and it will merge all of the raster values. You can see we have all the interpolation values here. Now we will move to Excel to determine the changes. In Excel we have copied this data. Now we'll just calculate RMSE error for the 4 different interpolation techniques. So we'll write up the formula here. So the formula is square root of sum square. Then we will choose the observed dataset, and we will subtract it from the test dataset. Now we will just divide it with counter of observed, and then we'll just end this formula, and this is our RMSE value. For the other interpolation techniques, we'll just copy paste and change the cell value. For natural neighbor, we'll just replace with C. For Kriging, we'll just replace with D. For IDW, we'll just replace with E. Now we have our values. From these values, we can actually tell that the lowest value is from IDW. So from our analysis, we can tell that IDW is better for this mineral analysis over Bangladesh. So that's all for now. Thank you for watching.